Alright then. Let's start our class today. So let's see where we stopped the other day. So we stopped at similitude law, if I'm not mistaken. Okay, similitude. So I'm going to change slide. Sorry, I think my screen was frozen a bit just now. I also have internet connection problem. Okay. Guys, are you able to see my slide right now?
Yes, doctor.
Okay, great. So let's continue with our last topic of our syllabus. So it's about similitude for pump and turbine. Alright, you have actually learned this in your fluid mechanics, right? About the geometric, kinematic, and dynamic similarity. If you still remember when you do, when you are trying to develop formula using Buckingham Pi theorem or Rayleigh theorem, you actually do some similarity analysis, right? So let's take a look at what is it about this geometric, kinematic, and dynamic similarity. Okay, so um, basically we have geometric, kinematic, and dynamic. You know your fundamental quantities. Okay, your fundamental quantities are length, right? You have mass, which is denoted by m, and also you have time, t. Sometimes the MLT also is used interchangeably with force F, alright, the symbol F. Okay, now for geometric quantities, is actually only, it deals with L. It doesn't matter, it could be L squared, right? That means in terms of area, it could also be, it could also be L squared, okay? That means this will be the length, you have area, you have volume, it doesn't matter as long as it's just dealing with L, right? The dimension. So this is geometric quantities, alright? And then kinematic, it deals with L and T, alright? Doesn't matter. It could be, alright, it could be velocity, it could be acceleration, and anything where you have L and T term, or it could be just the T term, alright? This is the frequency lah, basically, frequency. And then dynamic deals with all three, but it could, well, The compulsory one is the mass. Okay, it could be the combination of MLT, it could be combination of MT or ML. Alright, so for example, you have force, or the simple one is density, which is who remember the formula for density? Anyone? Do you agree with this? It's actually mass over density is mass over volume, right? I thought somebody coming in. You still remember that? Yes, okay, good. Okay, so it's mass over volume and density, and the force law. Alright, what is the formula for force? Do you still remember? If you don't remember, it's actually force is actually pressure over area. Okay. It's pressure over area. So pressure, what is the formula for pressure? Do you still remember what is the unit? Anyone can give me? E is also equals to rho GH, right? Agree on that?
Yes, doctor.
Okay, so what is this unit here? Do you still remember? So this is, and then I have L squared, so L cubed. So I could have M, L negative 3, P negative 2. Alright, so this is a force, alright? So this force, alright, sorry, squared. Okay, this force, sometimes they'll just use F, alright? I hope you realize that, eh? Okay, so sometimes it's easier to remember the formula, right? And then you can actually come up with the unit, basically. Yeah? Alright, so this is actually you have learned all this in your fluid mechanics in your year 1, eh? Okay. So if you look at this, it's actually explaining lah, alright, about the if we are studying about the similitude, we have geometric similarity, kinematic similarity, and dynamic similarity. Okay. Okay then. Now, skill ratio. Okay, the difference normally we will be using model and prototype, or it could be homologous machine, for example, homologous pump or homologous turbine. Okay, it doesn't matter. Now, model is the structure, or it could be object which is developed to represent the prototype. Okay, what is prototype? Prototype is actually the actual machine, or normally you build prototype when you first want to build something, right? You call it prototype. Okay, it's the actual object or structure, basically. So sometimes, well, this model, right? Sometimes this model could be smaller. Sometimes it could be larger. Okay, for example, you remember, for example, okay, if you want to test a dam, all right, a dam, you could build a small version. That means you build a model, okay, and then you can actually do experiment and things like that to get, the required parameters that you want. You want. That means you want to, report the report its characteristic, basically, yeah. And then, for example, larger model could be such as, the easiest one I could give you As example would be, these electronic chips, right? Our handphone, right, the chip is so small. So if you want to build model, okay, you could have a larger one, so you can test on it lah, basically. Then you can actually, once you have already have all those characteristics tested, then you can actually scale it down back as the prototype or the actual structure itself lah. Okay, so not necessarily model is small size, it could be smaller or bigger, right? It depends on how easy we are going, because we are testing it. So how easy it is, or economical wise, is it more economical to build a smaller or larger? It depends, right? So what are the advantages of studying this similarity? Where we have prototype or model, right, studying it. So the performance of object can be predicted, object or structure, it doesn't matter. It's more economical and easier to build, okay? You can actually test, for example, if you want to test them, right, it's so difficult if you want to build the actual structure to test it, so you might want to scale it down, and you can actually do experiments so many times, right? And the third advantages given here, actually there are more advantages, all right? We just listed 3 here. So non-functional structures, for example here, SDAN, right, it's actually non-functional, okay? The function is actually to store water behind it, right? So that means increase the head, right? Such as dam can also be measured, right? This is the model and prototype of turbine. If you look at here on the left hand side, right, this one is the model, okay? This is the prototype, this is the actual. If you have been to our water engineering lab, right, you could see smaller, the model, alright, smaller size of fountain. But in actuality, the fountain turbine is so huge, because this is used, one of the function is to generate electricity, okay? So you should use a big one, definitely, right? Okay, now we have come to the time where we want to do, or we want to carry out some analysis. This is on similarity in pump. We have similarity in pump, we have similarity in turbine. Basically, the similarity law are almost the same. Later, you can actually compare both slides. For similarity in pump and turbine, the formula is actually the same except for one, but it will still come to, well, it just, I guess it's just either square root some one value. It could be this, alright, square root h n over d. But let's we'll go there later. Okay. So how do we use this simulated law? Right. Okay. Let's show you how you are going to use this law. Okay. Now, if you look at your slide, if you have your slide, right? Okay, let's have our slide next to each other. So if you look at this, okay. Now, if you look at this, right, you have a simulated law for head, simulated law for discharge, which is represented by the simple CQ, and then you have simulated law for power. Okay, how do we use this? Okay, for example, if you have, model and prototype, right? If you want to analyze, for example, you want to know about the model, or even the prototype, you already have the measurement for the model, right? So what you are going to do is, for example, if you have, you have only one unknown, if you are comparing model and prototype, you can use, either one of whichever unknown, whichever are available. Okay, you are going to sort of evaluate which one should be used. All right. Later, I'm going to show you one activity and how you are going to use this. Now, you have this law, right? Basically, for example, you have H. This is a law for head and squared T squared. Okay. Now, if you are comparing between part model and prototype, you should equate it. It's the same formula, all right? But you should write down, one side is for model because this is the similarity, okay, and the other side for prototype. It could be, all right, the question could ask you to compare between two homologous palm or turbine, for example, palm A and B. So what you could do is, all right, you would have also n d squared palm A and palm B. So that's how you are going to, write it down basically. So similarly for, the law for discharge and power. Okay, so that's how you do it. I guess, okay, before we go to the activity, right, there's another thing. This is about specific speed. Okay, specific speed is not the same as the speed. The speed, if you look at this, there's a subscript S there that represents specific speed. Specific speed, there's no unit. Okay, it's dimensionless. However, of course, your speed has a unit, which is a revolution per minute. This is the formula for specific speed. Now, if you are talking about two homologous palm, right, they are going to have the same specific speed. You can actually check. Alright, but if you don't have time, you just calculate the specific speed for one, either palm or, either model or prototype, it doesn't matter, or A or B, alright? So, this is how you compare it, alright? Okay. Now, let's go to one activity. I know the solution actually for all these activities are available in your notes already. But let's go to one activity 6.6. So you have two homologous palm A and B. Now how are you going to do this? Okay, so let's write down. Okay, probably you are going to have your formula given to you, the simulated law, which is for the head, which is this guy here. Alright, you are going to have for discharge. For discharge would be, and then for simulated law for power would be, okay, alright, so you have that. Now, to solve for this equation here, or this activity here, you have two pumps. Okay, what I'm going to do is to make my, to make the activity simpler, what I'm going to do is, this will be the variables. But it depends on how you are going to do it, but if you tabulate all the data, it's actually simpler. Okay, so I have speed, which is n. I actually have the activity give diameter. I just put D, and then what else? Discharge, and then what else? Head. Alright, and then that's it, I think. Alright, but of course you also have, if I look at the question, you probably need to find an S, it doesn't matter. Okay, now this is speed. Okay, now A and B, they have the same speed. Diameter. This is palm A has impeller with diameter of 0.5 meter. Alright. Discharge 0.4 meter cube over second. This is for palm A. And then what else? The head is 50 meter. Alright. Now, what are the, so this is unknown, except for specific if discharge for palm B. So discharge for palm B is also given. Okay. So the question asks us to find size, which is the diameter, net height, and also the specific speed. Alright? So specific speed for A and B, because they are homologous, they should be the same. It doesn't matter, you can just use one. Now, if I were you, right, the specific speed that I'm going to calculate, I'm going to use these variables here, this value for pump A. Why? Because if we have error, alright, in our answer here, it will affect this specific speed. Since this is provided already, it's easier. Okay, you search for your specific speed for using pump, the data for pump A. Okay, now that's why it doesn't matter. Okay, now you have this data provided to you. Now, if you are going, let's just reduce this. Okay. Now, let's say, let's look at this law here. Can I ask, is Aiman there? Aiman?
Yeah.
Okay, Aiman. Can I ask you, which law can I use first? I cannot use this, right? Because, can I use this? Because actually power is not needed, right, in the question, right? So between these two, which one can I use?
Soalan dia sebab nampak.
Oh, no, okay.
Sorry.
Okay, it doesn't matter. Okay, here is the question. You should be able to look at the question already, kan? Okay. So, you want to use this, right? Okay, because if you use this, sebab apa?
Tak, bagi saya sebab information dah cukup.
Yes, you're right. Because the only unknown would be dB. The rest are all known kan? Q ada, QA, QB ada, NA, NB ada, DA available only this kan? Thank you Aiman. Alright, but if you are using this first, okay, if you are using this first, you have two unknowns, alright, so you can't really solve it. So we are going to use the law for discharge first, alright, so let's try it out. So we have Q over N dQ. So we are comparing pump A and B. So I have here, alright, okay. So the thing that all these are available, the only unknown would be this dB here, which is the diameter for impeller pump B. So I'm going to rewrite this. I have dB cubic power equals to QB over QA. Alright, so I have NA over NB times, this is actually times dA cubic power. Okay, so that's how I just arrange it according to the same parameter. Okay, so dB cubic power. Okay, what is my QB? Is 0.3 over 0.4 times. Okay, I know that this is the same. I don't mind you want to write 600 over 600, it doesn't matter, or you can write 1. Because you know they are the same, right? Okay, it's actually, it will actually give you 1 basically. So what would be our dA? It is 0.5 cubic power. So dB cubic power, I think if I'm not, help me calculate, if I'm not mistaken, I'm not sure whether this is correct or not, but please help me. So dB is 0.4543 meter. So if you want to give in terms of centimeters, this is a question give you in centimeter, you could also write this in centimeter. Alright? Okay, that's it. Okay. So, oops, you cannot see it. Okay. It's simpler, right? It's simple, right? It's quite straightforward. Okay. So after that, of course, you can solve for, after you have determined pump size of pump B, you can solve for net head because D and for A and B are available. So, right? Also, HA is available. I know that I put here M and P, which is the model and prototype, but you can actually change it to pump A and pump B. Alright. So if you look at the solution provided in your slides, right? It gives the same answer as us, alright, which is 45.43 centimeter. And then after that, we use the law for the head. Okay. So similarly, you are going to arrange it so that the unknown would be the subject of your expression. So you get 41.28, right, meter. So now you know, okay, which one basically, the table is here. So between A and B, which is basically, they are homologous pump. And then if you compare the diameter, pump A is actually larger than pump B, okay? And I would actually expect, the discharge is larger too for pump A. And I actually would expect the head for pump A is higher than for pump B basically. But not necessary, you just have to be careful, not necessary in all situations. So basically, for this, after that, the last question that they ask is to find specific speed. If you look at here, right, okay. If you look at here, the specific speed, right? Where is it? Okay. You could calculate for pump A, it doesn't matter. Alright, if you calculate for pump A, you'll get 20.18. No unit, okay? Or you can calculate for pump B. If you don't have time, you don't have to check, okay? This is just checking, but it's not, as long as you give the specific speed for one pump, it should be the same with the other, right? So far, do you have any question so far about this similitude of pump? Anyone? Ada soalan tak? Semua faham
Faham, Doktor.
Okay, great. Okay. Alright. Okay. Now, so we look at similarity in pump. This is similarity in turbine. So you have this law of head, discharge, and power as well. It's similar. Remember that just now we use m squared d squared over h, right? It's actually similar. It's the square root of r, right? The term. Okay. Of course, the law for discharge and power is the same Okay, you have Q over D. It's the same as the law for pump. This is the same too, right? Now, it is how it works is the same, You are comparing it between model and prototype, or any homologous turbine basically, A, B, or 1 and 2. Okay. So now, okay, remember here, there's a difference in formulas for specific speed. Be careful, here's the thing. Just now, if you look at this, the specific speed, you actually, in pump, you use discharge. Okay? But in turbine, you actually use this power here. Alright, square root P. Alright. Okay, this is basically you have power turbine utilizes the energy of water, right, to produce mechanical power and things like that also pump is actually supply energy to water basically. So there's a difference there, alright. So this is the formula, specific speed for turbine, alright. Be careful, if you look at here the unit, just be careful of the unit, where N is in RPM, H is in meter, but the power is actually in kilowatt, not just watt, but in kilowatt. So you have to be careful when you are using this specific speed formula. Alright, when you are calculating it, the power should be in terms of kilowatt. So you don't have to times 1000 anymore. Alright, so this one no need, because there is no power involved here. Alright, except for turbine. So pound is just you are using meter cube over second. Except for turbine, turbine you have it in kilowatt. So it's actually the same steps lah. Alright. Okay, so you have here activity 6.7. Okay, so you can try this out. It's similar. You have to try it out because you actually here's the thing. I feel like you should try it on your own because the solution is here already. Try it out. Work on it yourself, because if you are listening to me, right, you won't. I don't think so. You want to try it out yourself, lah. Okay, so try this out yourself. I hope you still remember our last lesson where I told you for pump and turbine, there's a difference between input and output power. Okay, can I ask somebody? Is Amira Afika here? Amira Afifa? Amira? Amira, you sound very slow, very low, your voice. Could you speak louder? Amira, my question would be, for power, what is the input power?
Power yang masuk kat dalam, kiranya power
Mechanical ke flow ataupun yang water lah. Let's just assume water as a fluid. Yang mana? For pump, inputnya mechanical ke water?
mechanical.
Okay, correct. Output is? Yes, correct. You're right, because it supply energy to the flow. Alright, thank you. So turbine is the other way around. Thank you. So can I ask somebody else? Is Ahmed Muhammad there? Ahmed Muhammad. Is Ahmed Muhammad there? Okay, since you are not there, can I ask Awatif then? Awatif?
Yes, Doctor.
Okay, Awatif. What is the formula for efficiency? Is it input over output?
Sorry, Doctor.
Here's the thing. How most probably the formula will be given to you, like it doesn't matter. But if you want to find the efficiency, right, you put in something, how much it goes out, alright. If it goes out 100% from what you have put in, that means the efficiency is 100, right? But as you know, the efficiency is rare. You won't get 100%, right? It must be less than 100, right? So what is coming out, that means is output power divided by input. Then definitely you are going to get less than 100, am I right? Because you won't get, yes, great. Okay, that's how, you can actually remember the formula lah. But of course, you don't have to remember it because it's actually provided lah to you, right? Okay, now, let's go back. I hope we can try all this out because the solution is provided already in the question. The final topic that we are going to look at, right, is the performance of turbine under unit quantities. Now, this topic is actually if you want to find the discharge the speed power for a particular turbine or even pump, assuming same efficiency under a heat of 1 meter. When we talk about, finding some performance, okay, under a net heat or a unit heat, you can use this similarity. Now, what similarity is this? You have unit discharge, right? The formula will be Q over square root H. Now, between two similar turbines, look at this. You are going to have, that means turbine 1 and turbine 2, right? You are going to write down your formula Q square root H, left and right. So you are going to put the subscript for that represents turbine 1 and turbine 2. Alright. Similarly, you have unit discharge, you have unit speed, and you have unit power. Alright, this is the formula. So, in your formula, if we are going to give you formula, most probably we're just going to write N over square root H. Sometimes we'll give you NU lah, but if we give you N over square root H or P over square root or P over H to the power of 3 over 2, I hope you know these are. Look at this, the formula is actually overhead. This is overhead. This is overhead. It has discharge overhead. It has speed overhead and power overhead. So these are all working under a unit head. I hope you can distinguish between this and the similarity law that you have learned for pump and turbine. Alright. So this is all about when we talk about unit speed, unit power, unit discharge, right? It's actually you want to find out, alright, the performance of turbine working under a unit head lah. So you have this formula. So let's look at one activity here. You have activity 6.8. You have a Francis turbine, okay, that produce. This is the output power, 6,750 kilowatt of power at speed of 300. Net heat of 45 with overall efficiency of 85% or 0.85. Now determine the speed discharge brake power of the same turbine under a net heat. Alright, so you are comparing, okay, of a net heat. You actually want to find out, under unit heat, how does it work? What is the discharge, the speed and brake power lah in homologous condition? Okay. So if you look at, if you are using the unit speed, okay, again, what you can do is you probably want to list out all these variables. You can actually tabulate it, such as the one that I showed you earlier. So you know which one is available, which parameter is not given. Okay, so for example, in this case, right, H1, H2 is given. Alright, you can find N2. Alright, the only unknown is speed for turbine 2. Okay, so rearranging it, you can find the speed. Okay, now in order to find the discharge, okay, you actually have to find out the discharge first. Okay, the discharge, your efficiency is given as 85%, which is 0.85 lah, alright? So the input, this is turbine, right? So the input power would be the flow, water, the flow power or the water. So you have the formula of, that's why it's actually, that's why last class I explained about, the difference between pump and turbine, and I hope by now you should know, between each machine, what is the input and output power. For example, here, you know that in output divided by input will give you efficiency. Output is actually provided, which is 6,700 in the question, kilowatt, it gives you. So if you want to find the discharge, okay, so an efficiency is provided. H is given, of course, the specific weight would be rho times G lah, which will give you 9,810, which is 1,000. You are assuming water times 9.81. Okay, so you are going to get discharge lah for turbine 1. Okay, because all this value you are using turbine 1 value. So discharge is 17.99. Okay, there are cases like this, they give you output power efficiency, but the only thing that you need to find is discharge lah, because there's no discharge provided, but you know that using this and this you can get your discharge. Okay, so after that, once you have Q, H1, H2, the only you can actually obtain Q2 lah using the unit discharge formula. So you have that. Okay. And then after that, okay, since you already have power for now, this is what power, both are power, mechanical power for turbine. Don't get confused. This is not about input and output. This is actually mechanical power. Look at this. The mechanical power for pump 1 is 6,750, which is provided. So now you are actually looking for mechanical power for turbine 2. Okay, so substituting all those given data, you have your mechanical power for the turbine to be which is the output power to be 10,392 kilowatt. Okay, so okay, that is all for our class today. So do you guys have any question? I will actually try to return all your assessment by some of it maybe this Thursday or some of it next week, because I just need time to focus. I'm just doing too many things currently. Okay, so do you have any questions so far, guys?
Doktor,
Yes, yeah. Awati.
untuk yang calculation yang last tu, yang untuk mechanical power tu, nama unit dia nanti akan dalam kilowatt
No, actually, except for the specific speed for turbine, the unit will be kilowatt. But in this case, right, let's go back. Let's just go back. Alright. Okay, now let's look at this. Awati, can you look at this? Can you see the slide?
Yes, doktor.
Okay, great. Now, if you look at this, right, P1, actually, if you are supposed to have 6,750 times 10 to the power of 3, okay, but since both, actually, you are using the same formula, if I have 10 to the power of 3 on the left and right, at the end, my answer, if I simplify it into kilowatt, I'll get this as well. So I can actually, since I'm using P1 in kilowatt, I can have my answer as kilowatt too, because left and right formula are the same. Is it okay?
Okay, doktor. Thank you.
Great. Because, apparently I can cancel off that 1,000. It's not cancel off the 1,000, but it has the same unit. Okay? Okay then. So, any other question? So please try it out. You actually have the solution in your slide already. Try it out. Now, if you need any slides, I think the other day I finished the solution for chapter 4, but I forgot to share. Anything, just WhatsApp in the group. Okay, I'll respond to you. Okay. Now, that would be our last session for our syllabus. Next Thursday, I do hope you all of you can join me because I'm going to give you some, let's go through some of it's not well, I wouldn't say it's revision, but I'm going to highlight some things, some topic that you need to know lah for your final exam, and it could be just half an hour if you guys are on time lah. Basically, we will normally start at 8:15 lah, so be on time, right? Okay. If you don't have any more question, I'll end my session now. But for those who have already set out appointment with me for your interview, stay on, right? Okay, I'll see you guys.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
You're welcome.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you.
Doktor,
Ya, Zata.
boleh saya Doktor ada pasio yang 2020 punya, sebab yang dekat library tu hanya ada yang 2019 dengan 2020.
2020. 19.
Selepas ni.
Semester lepas. Yang itu saya kena dapatkan dari penyelaras. Cuma biasanya yang online ni diorang tak share tau. Sebab diorang risau student basically ada soalan, ada yang diorang kita masuk bank soalan, dia akan repeat. Jadi mungkin susah saya nak bagi juga tau Mas Dato'. Tapi saya cuba, nanti apa-apa saya akan bincang hari Khamis ni, boleh Mas Dato'? Sekiranya tu jangan risau.
Okay, thank you Doktor.
You're welcome.
Thank you, Doctor.
You're welcome.
Doktor nak tanya.
Ya,
Interview last bila Doktor?
saya bagi sampai sebelum final exam paper you guys.
Kiranya kalau time study week pun boleh lah Doktor?
Boleh, tak ada masalah. Janji semua all members are present.
Okay. Thank you Doktor.
You're welcome. Okay, 10 of you belong to 2 groups, is it?
Ya, Doktor.
Can I have one group first?
Group 7, Doktor.
Group Siti Nur Syafiqah, okay. Satu lagi group, siapa leader you? Yeah, Syafiqah, siapa member you?
My group member ada Vasuntra, Aisyah Farhana, Nurina dengan Nazira.
Okay, so Muhammad Farhan bukan group you
Bukan.
Okay, Farhan. Saya rasa dia ni tinggal ni. Tak apa, mungkin dia pergi washroom ke apa, jadi saya akan keluarkan dia. Remove. Haris Izzuddin?
Bukan juga.
Bukan Haris. Dia tak dengar tu, maknanya dia dah tinggalkan lah. Okay. So, siapa lagi yang bukan ni?
Izzat, bukan.
Izzat, Muhammad Izzat. Tengok panggil dia pun dia tak sahut. Okay. Alright. So, 5 of you Okay, good. Okay, satu group je lah, senang je saya. Okay. Boleh tunjukkan report UR tak? Untuk saya senang, saya tak payah cari dah. Switch on, bagus. Looks like you are in a wedding reception, Mas Indra. That's so nice. Yang lain kalau nak switch on pun boleh, senang. Saya tengok reaksi muka you guys.
Doktor nampak saya tak? Saya buka tapi.
Nampak dah Syafiqah, dah. Nampak background.
Doktor.
Boleh.
Okay.
Mana Aisyah dengan Nurina dan Nazira? Ada
Ada tu.
Kejap doktor.
Okay, tak apa. Wah, comelnya.
Saya tak boleh buka. Ada nampak slide tak? Saya slide report.
Dia tengah nampak dah. Okay.
Okay, ni nampak.
Okay. So, saya ada okay. Sekejap saya nak tengok student name dulu. Okay, you guys 5 of you So,
Ya.
dalam report you guys, ada tak tulis siapa buat apa? Peranan masing-masing?
Sekejap.
Kalau tak ada, boleh saya dapatkan info tak?
Okay, macam kalau part calculation saya buat.
Syafiqah buat calculation.
Saya dengan Vasuntra lah. Buat
Okay.
yang untuk catchment area.
Okay. Lepas tu, kalau tak apa. Saya nak submit dulu. Nanti soalannya saya simpan. Jangan risau Syafiqah. Okay, tak apa. So, Nurina apa?
Saya buat conclusion dengan discussion.
Okay, jadi kalau conclusion discussion ni mungkin saya akan tanya intro lah. Okay. Nak Aisyah?
Saya buat metodologi.
Method. So kalau saya tanya tentang analisis, tahu kot?
Apa dia?
Kalau saya tanya tentang analisis, boleh jawab kot? Okay, last kali dengan Nazira. Nazira, handle apa?
Nazira pun buat metodologi juga.
Okay. Boleh. Siapa yang buat drawing
Yang drawing yang mana doktor? Yang untuk yang tentukan
tentukan arah aliran, tentukan size.
Saya
Okay, right. Banyak nak buat benda tu, okay.
Tapi bincang jugalah dengan yang lain.
Okay, tak inilah waktu saya tengok siapa yang bincang, siapa yang tak bincang.
Okay.
Alright, boleh. Saya nak tanya Nurina dulu. Sekarang satu soalan je, sekejap je, 15 minit je Nurina.
Nak buka ke mana dulu? Nak buka projek, nak buka report dekat bahagian Nurina dulu lah.
Tak nak. Sebab ini projek teamwork, jadi Nurina patut tahu benda lain juga. Sebab tu saya sengaja saya dapatkan info dulu siapa buat apa. So saya boleh tanya benda lain. Okay. Nurina, you buat conclusion dengan discussion kan?
Ya doktor.
Okay, jadi boleh tak explain macam mana group you dapatkan arah aliran? So sekarang ni Nurina ataupun Syafiqah kena tunjukkan drawing yang ada arah aliran, lepas tu Nurina kena explain.
Kejap doktor.
Boleh? Tak apa. Take your time.
Tapi drawing ni by macam by apa ni ikut drain macam interceptor drain, dia tak ada keseluruhan.
Oh, tak apa. Tapi ada arah aliran ni tak? Yang ke
Saya ikut yang gambar warna ni.
aliran direction.
Apa dia doktor? Tak jelas.
Lagi bawah yang table hari tu kita buat tolak-tolak tu.
Tolak-tolak.
Di bawah
Sorry tak dengar. Jadi ni.
bawah lagi.
Oh,
Dari bawah ke atas yang first. Yang table tu.
Table. Oh, yang kat Enfield tu ke?
Sekejap sekejap. Lagi atas saya rasa.
Yang ni ke?
Ni. This one right doctor? Is this one?
This direction of flow. You have it?
Ya.
Okay, nampak tak boleh?
Saya nampak. Tapi direction of flow ni untuk drain yang mana? Interceptor ke roadside drain ke bench drain?
Yang ni untuk overall. Kalau untuk yang by drain, kita kena refer yang sini doktor. Yang saya buat satu-satu. Macam ni.
Sebenarnya Nurina kena jawab tak?
Okay. Jadi dah jawab.
Syafika dan Suntra yang buat benda ni, jadi saya tak nak tanya.
Okay, sorry doktor.
Nurina, okey tak? Nurina, boleh explain tak?
Ya doktor.
Boleh explain macam mana dia orang dapatkan arah aliran tak? Sebab semua orang kena tahu tak?
Tapi yang ini saya buat yang part apa tu? Sekejap.
You buat kesimpulan kan? Lelaki kena tahu tak?
Kalau interceptor drain ni
Okey, paling senang guna yang bench drain saja. Boleh explain arah aliran ni tak?
kalau bench drain dia dengar kan? Doktor dengar kan? Kalau bench drain dia yang belah kiri tu kan nanti ada tolak-tolak nilai tu kan?
Kenapa yang kena tolak nilai?
Tolak nilai level tu sebab nak tahu level dia, catchment area kita tu.
Tapi aliran bergantung pada catchment area ke?
Ya?
Adakah penentuan arah aliran bergantung pada catchment area?
Tak, level dia, level.
Level dia kan? So aliran bergerak dari kawasan rendah ke tinggi ya?
Dari tinggi ke rendah, kiri ke kanan.
Kiri ke kanan. Kalau saya tengok graf tadi macam tak semestinya.
Dia yang bench.
Graf tadi Syafika atas lagi
Atas sekejap
nampak tak ni? Ini direction of flow untuk interceptor ke untuk roadside drain?
Apa doktor?
Nak tanya graf ni kan yang ada direction of flow ni, adakah berdasarkan
saya boleh jawab ke?
tahu arah aliran untuk interceptor drain dan roadside drain?
Kalau yang ni buat yang based on menyeluruh, macam kita tengok dari challenge 275 sampai 500, kita orang buat yang menyeluruh. Untuk tahu yang by section tu kita tengok dekat yang macam saya tunjuk tadi tu. Untuk tahu
Tapi arah aliran tu ID dengan RST lain tau.
lain, semua lain. Dia sekejap doktor. Kita saya boleh terang ke doktor?
Okay, Norina perlu lifeline
Dia belum lagi.
Okay. Terang Syafika.
Lepas tu nak buka kat graf tadi ke macam mana?
Tak apa, Syamika tenang je sampai saya faham.
Okay, macam ni untuk saya tentukan intercepted drain, kita tengok dekat finish level, dekat cross section kan. So untuk intercepted drain, chainage yang ada daripada 300 sampai 475. Jadi okay, kita kalau tengok kat sini warna merah ni, channel 350 ni adalah finish level yang paling tinggi. Bermaksud aliran akan ada ke kiri dan ke kanan. Maksudnya kat sini akan ada ke kiri dan ke kanan.
Yang finish level ni tengok dekat
Cross section.
longkang interceptor kan? Longkang interceptor kan? Dekat interceptor drain kan? Lokasi interceptor drain. Okay.
Tengok dekat cross section yang untuk interceptor drain. Lepas tu kita kita akan tahu flow, kita akan tengok yang mana area lagi besar antara kiri atau kanan. So macam untuk interceptor drain ni, kalau kita tengok antara dua ni, flow belah kanan lagi besar. Jadi kita consider belah kanan.
Okay, boleh. Boleh tunjukkan arah aliran untuk roadside drain?
Roadside
So
drain.
kat sini pemisah dia 350 kan?
Roadside drain. Sekejap
Okay.
Okay, ni roadside drain. Untuk roadside drain, kita ada dari start chainage 300 sampai chainage 475. Chainage yang paling tinggi adalah dekat chainage 400 iaitu 68.922. Maksudnya maksudnya dekat sini chainage 400. Tapi kalau based on drawing ni, kita tengok belah kiri lagi besar. Jadi kami consider untuk belah kiri, ambil area belah kiri.
Okay. Tapi boleh.
Kenapa dah tu?
Tapi hati-hati tau sebenarnya kalau you nak design ini sebab you design roadside drain kan. Kalau interceptor drain sebenarnya sebelah kanan lagi besar tau sebab you punya ni dekat 350 kan.
Interceptor drain interceptor drain memang saya ambil belah kanan doktor.
Betul lah. Okay. Okay. Boleh. Okay. At least saya nampak you faham jugalah Okay. Alright. Thank you. Marina nak soalan lagi tak? Okay. Since ini soalan mudah je tau. Apa yang Marina dah belajar daripada projek ni? Ni soalan ni mudah je. Tak ada betul salah.
Kalau based on yang saya buat conclusion dengan discussion tu, saya macam kena tengok yang Q design dengan rational tu.
Yang mana yang patut lebih besar untuk menjamin drain tu untuk menjamin kata drain tu mencukupi lah dari segi kapasiti dia. Q drain besar ke Q rational?
Q rational.
Kalau Q rational datang dari hujan kan? So kalau kata Q hujan lagi besar daripada
Q design.
Okay, nasib baik itu kelas jawapan. Kalau tidak dia menentukan. Okay. Alright, Norina, itu soalan you. Kemudian saya nak tanya Nur Aisyah. Okay, Nur Aisyah, kenapa boleh tahu tak design untuk roadside drain you guna roadside drain type jenis apa? Type 1 ke type 2 ke? Kenapa you pilih roadside drain type 2? Soalan saya, kenapa pilih roadside drain type 2? Roadside drain banyak type kan? Type 1, type 2, type 3. Kenapa type 2?
Sebab senang untuk bina dekat site. Dia punya site tu dia level dia tinggi.
Okay. Level tinggi bukan lagi susah ke nak naik? Sebab ni kelas in situ kan. Kalau you kata nak mudah, you boleh letak precast. You boleh pilih RSD 3. Betul tak? Ini kelas in situ maknanya you bawa concrete, you kena buat kelas in situ lah. Ya, ada kawan nak tolong tak, Aisyah?
RST2 type 2 we use maybe because the paper is cast in situ V-drain. Okay, it's usually it's done in the site, and the concrete has a rough surface to reduce the rate of flow, and also it is between the proposed road and the higher level of land besides the road.
Okay. No, actually, right, safety wise, ramai yang tak suka sangat lah RSD tu sebab kalau kenderaan kan terbabas kan, dia bahaya tau. Berbanding RSD3. RSD3 kan dia macam macam egg-shaped kan. Cuma sebenarnya saya nak tahu sama ada jawapan ialah kenapa you pilih RSD Type 2 ni sebab lebih senang nak kira. Dan macam betul ke? Okay, maknanya terjawab lah soalan saya tu. Okay. Alright, okay, thanks Aisha. Nazira.
Yes.
Nazira pun buat metodologi kan. Nazira boleh tak tunjukkan macam mana Nazira tentukan not untuk interceptor drain?
Tak dengar lah.
Not untuk interceptor drain. Not. Dengar tak?
Tak.
Unlock.
Not. Nak cari T-not?
Oh no.
Oh.
Nak cari T-not, you perlu dapatkan not dulu kan? Panjang overland length of flow. Length of overland flow. Not. Macam, okay. Okay, thank you. You ada 25 meter, things like that. Tapi datang dari mana, Nazira? Macam mana you dapat 25 meter ni?
Dari sekejap sekejap.
Tahu betul.
Sekejap.
Maaf, saya kena tanya semua orang sebab saya nak pastikan dia orang betul-betul faham tak apa yang tengah buat. Jangan Syafiqah yang langsung je lalu.
Dari sekejap je.
Boleh. Siapa yang masuk?
Sekejap. Tadi nak dari segitiga kita.
Segitiga? Macam mana? Kenapa you nak buat segitiga tu Kenapa guna segitiga tak guna segi empat?
Okey. Kita orang ambil panjang ukuran daripada gambar.
Gambar apa?
Gambar yang sekejap Syafiqah tu. Okey, kan ada segitiga kan? Yang 1, 2, 3.
You pilih segitiga mana?
Yang satu. Yang first.
Yang warna apa? Kita ada kelabu, kita ada kuning.
Kelabu.
Okay, 25 meter tu jarak dari mana ke mana?
25 meter jarak daripada yang tu. Yang antara challenge 275 ke 300. Macam tu.
Betul ke Bahasa Inggeris?
Each channel 25 the jarak. So let's say example channel string ada tu channel tu ada 25.
Bukan. Syafiqah?
25 tu untuk setiap challenge. Cuma yang untuk 297 tu kita ambil based on yang ni. Kita buat gambar.
Okay. Macam mana you ukur dekat gambar boleh tunjukkan tak? Alamak. Syafiqah Han ke saya yang Han?
Syafiqah.
Okay. Okay. Tu dah.
Betul?
Ya. Macam mana you dapat 25 meter ni? Syafiqah dah hang kan?
Oh sorry doktor, line lagi tiba tak ada.
Saya faham. Semalam pun saya dengar. Semalam pun saya ada masalah sama, saya faham.
Okay. Nampak tak?
Nampak. Nampak Rifat, nampak.
297 sama dengan 25 tu bermaksud kalau tengok kat gambar ni contoh 297 ni kita ambil yang dari gambar tu, yang kita tarik straight line ni kita dapat
Okay. Soalan saya not tu. Saya ukur dari mana ke mana? Boleh tunjukkan tak? Not ukur dari mana ke mana? You dapat 24 point something tu kan?
Sekejap Oh yang ni ya.
24 point something tu.
Saya ambil daripada contoh
Boleh?
Saya ambil yang TO kat sini. Itu sekarang panjang. TD dia.
Okay. Itu yang saya nak jawapannya. Tunjuk sekali lagi mana not you? Situ kan? Okay, maksud LD. Lepas tu LD nya?
Dia, sekejap.
LD. Tak payah you tunjukkan, you ukur dari mana ke mana je yang ni. Dari mana ke mana je?
Sekejap LD dia.
Ada seorang terkeluar, Nurina. Okay. Tapi Syafiqah sepatutnya sepatutnya boleh saya conteng sikit tak? Okay.
Boleh.
Okay.
Saya nak stop present ke macam mana?
Boleh juga.
Okay, start. Okay.
Nampak whiteboard saya tak?
Sekejap.
Tu saya kena share whiteboard.
Tak nampak.
Tak
asking request doktor kena share.
Saya kena share. Okay. Saya kena share whiteboard ni. Share. Okay, dah boleh masuk tak whiteboard saya?
No, doktor.
Belum lagi.
Okay, tak apa. Kalau gitu saya share screen saya. Okay, so patutnya dah nampak whiteboard saya kan?
Nampak dah doktor.
Okay, so tadi saya tengok you punya contohnya yang ni ID you kata ni segitiga you kan? Okay, tadi L ini ialah L0 you kan betul tak?
Okay.
Lepas tu LD you yang ni kan? Betul? Itu yang galak yang saya nak Okay. So, okay. Okay. So, sebenarnya saya dah habis soalan saya tau. Saya last kali, saya sebenarnya Syafiqah dengan Mak Suntra dah jawab banyak. Tapi last lah saya nak tanya Syafiqah dengan Mak Suntra you guys ada summarize tak size, ada table of summary buat size, table of summary untuk design size untuk drain, bench drain dengan roadside drain juga. Dan ada check tak velocity dalam drain?
Nak saya present report.
Boleh present? Ya, present.
Nampak tak report?
Kejap belum lagi kot. Okay. Nampak.
Yang untuk yang ni tu dah.
Okay.
Kalau untuk ni macam kita nak tentukan sama ada kita punya design tu lepas ke tidak, kita contohlah kalau kita tengok kat sini channel 500 kan, kita dapat capacity dia contoh 1.80 meter cube per second. So kalau kita tengok yang ni nilai ni lagi besar daripada design flow lagi besar daripada rational flow kita, iaitu 7.914 kali dengan 10 negatif 3. So maksudnya design ni acceptable lah sebab dia lagi besar pada yang itu.
Okay. So, tapi besar betul Okay, itulah saya risau beza dia agak tertarik juga. Tapi tak apalah. Memang unit you kalau dekat peringkat kedua tu? Have a rational flow.
Ini typo.
Okay. Alright. Ada check velocity tak yang saya kata kalau guna earth drain tu rasa tak boleh exceed 2 meter per saat, kalau guna concrete drain tu tak boleh exceed 4 meter per saat tak? Yang tu ada tak check?
Concentrate ada.
Which one, doctor? Sorry, I don't get you. Sorry.
There's actually sort of limitation to avoid sedimentation and to avoid
below than 2.0 meter.
Did you check on that?
Actually, yeah.
Yes, no?
Yes. I think doctor.
Yes. No je jawapan dia.
For the slides, we use
tak apa ya central, kalau tadi tak apa. Okay. No, don't worry, it's okay. I think most probably most of the group pun tak buat jangan risau. So itu saja kot soalan saya sebab saya dah tanya each of you. So thank you. At least I got to know how many of you really understand the project. Okay, thank you very much.
Doctor, is it you got specific answer like this would be this answer or it's just like still based on the calculation maybe?
Actually, there's a specific answer. However, there are bound to be some differences because the way you assume L naught, L D, the slope, type of channel, we are bound to have different answer. Don't worry. Okay? Jangan risaukan sebab cara saya ukur jarak anak dengan you ukur jarak anak tu lain kan? So jangan memang takkan dapat jawapan yang sama. Okay.
Okay, Doctor, I hope we did a good one.
No, it looks like you have done a lot, seriously. So don't worry, jangan risau. Okay. Alright, take care. Thanks,
Doctor. Thank you so much.
Okay.
Thank you, Doctor.
Thank you. Bye-bye.
Bye, Doctor.